Space is far bigger than you think. But here's the weird part. Humanity knows the approximate age of the universe, yet we still can't measure distances in space precisely. Measuring distances on Earth is easy. You use a ruler, a laser, or GPS. But in space, there's nothing like that. There are billions of kilometers of empty void, and we can't just go and measure. For example, the distance between Earth and the Moon is known very precisely, 384,400 kilometers. We know this because of mirrors left on the Moon during the Apollo program missions. A laser beam sent from Earth bounces off these mirrors and returns. By measuring the travel time of the light, we calculate the distance. With this method, we know it down to the centimeter. But you can't send a laser to a star. Take the closest star to us, Proxima Centauri. It's about 4.24 light-years away. 1 light-year is roughly 9.46 trillion kilometers, so this star is around 40 trillion kilometers away from us. Now think, measuring this distance meter by meter is impossible. That's why scientists use different methods. One of the most basic is the parallax method. As Earth orbits the Sun, the positions of stars shift slightly against the background of more distant stars. This shift can be as tiny as 1/1,000,000th of a degree. By measuring this angle, the distance to the star is calculated. But here's the big problem. The farther a star is, the smaller this angle becomes. After a certain point, even telescopes can't detect the change. That's why for more distant objects, other methods are used. For example, some stars vary in brightness at regular intervals. These special stars are called Cepheid variable stars. We know their true brightness. By comparing how dim they appear to us, we can calculate how far away they are. But space isn't that simple. Between galaxies, there are cosmic dust clouds. These clouds dim the light. So a star might actually be closer, but appear fainter. This introduces errors in the measurements. For even more distant galaxies, scientists use another method, redshift. Because the universe is expanding, distant galaxies move away from us. Their light stretches and shifts toward the red end of the spectrum. This effect was first discovered by Edwin Hubble, and it helped us understand that the universe is expanding. Today, using these methods, we estimate the observable universe to have a diameter of about 93 billion light-years. But here's a crucial point. When we look into space, we are not seeing the present. Light from a galaxy can take billions of years to reach us. So when we observe it through a telescope, we are actually seeing the galaxy's past. That galaxy may have already changed completely. It may have merged. It may no longer exist, but we still see it as it was. This is why measuring distances in space is not just measuring, it's also measuring time. And the strangest part? Scientists estimate the universe to be around 13.8 billion years old. Yet we still don't know its full size. Maybe the part we can observe is just a tiny fraction of the entire universe. So there could be things in space that it is physically impossible for us to measure their distance. And perhaps the greatest mystery of the universe is this: we can observe space, but we still cannot measure its true scale.